Hello, good afternoon, ladies and gentlemen. This, I believe, would be a very interactive session going ahead. My name is Sanjay Guhathakurta. I lead the manufacturing and metal mining industry in IBM India, and it is my privilege and honor today to have all of you in this webinar in this COVID-19 situation. All of us are locked inside our rooms, and hopefully, this knowledge sharing session that we want to take today um, is helpful to all of you. What we want to discuss with all of you today would be how Industry 4.0 would be could be important and useful for the MSME sector, and especially in this COVID-19 situation. I will touch upon that. I don't know if I see almost 100 plus people who have already joined. I believe I'm good to go now. One small point is, I don't know, some of you might have seen me. We met during the BCCI presentation a couple of months back. And this is a continuation of that particular discussion. If any of you have not been present in that MSME that particular conference, it would be a useful presentation for you as well. So before we start, before we come to the main topic, I'd like to touch upon this whole topic around what is Industry 4.0. Industry 4.0 is a topic that has been around. You see this topic in newspapers, magazines, and in many forums. What is Industry 4.0? So Industrial Revolution 4.0, or the fourth industrial revolution, or the Industry 4.0 as we call it. I wanted to spend some time, a few slides on that, in case many of you are not aware of what this term is. There have been four major industrial revolutions cutting across the entire world so far, till today. So if you look into this slide, Industry 1.0, basically this started in the 1800s, way back, almost 200 years back, where the production or mechanical production concept actually was introduced to the external world. I'll come to the subsequent slides what this is. Then we moved on to Industry 2.0, which was achieved by mass production or division of labor, and also the invention of electricity. The invention of electricity also led to usage of electronics, automation. Any industrial automation that you see in factories right now, in shop floors, is basically Industry 3.0. Industry 4.0 has been the topic that has come up in the last, let's say, 10 years, plus 10, 12 years or so, which uses a variety of things. Mainly, it uses something called cyber-physical models or digital twins, which basically replicates the machinery which you see in the shop floor and tries to understand and try to replicate the whole experience without getting into the shop floor. We'll see multiple examples as we move ahead. But to spend some time on the three topics which I just mentioned, the first, second, and third, this is the first industrial revolution, the quick change in the production. And way back in the 1800s, we saw that for the very first time, mechanical production came into the scene. Then we quickly moved to the and that led to almost 30 times increase in iron production. This led to the second industrial revolution, or the second wave, which basically you saw the mass production of iron and other metals, which led to the production of devices or assembly lines. The concept of assembly lines came up, and also during this time, electricity was also used. The usage of electricity was felt and necessitated in different parts of factories. That led to the second industrial revolution, and this obviously led to a significant increase in production. It coincided with the invention of the automobile industry, and people started to use it for commercial and private uses. 8x increase in car production. The third one was when people realized that there is a need to automate production using electricity, using IT, using electronics, and so on. So everything currently, if you walk into any factory, all of you, most of you are from Tata Steel, and the facilities that you see around you would be around the third industrial revolution. While I talk on it, the future of production, future of manufacturing also lies in the fourth industrial revolution, where it infuses the information and IT and communication and sensors and IoT and so on. We'll slowly see what that is. Before we jump into that, I was mentioning about this concept of cyber physical systems. If you look into this picture and try to understand, on the left side, you will find this is the left side of basically this slide is broken down into three different sections. On the left side, middle part, and the right side. The left side, you will find that these are different factories who are communicating through different communication channels. The data is taken to a central cloud. There are logistical partners associated. Everybody is generating different data. However, these are real data which are connected to the real world. I'm coming to the middle part of the slide. In the real world, all these data is being actually generated and being interacted by different physical systems. And you will find in that picture robots, etc., the machines generating a lot of data. Now, to take action to understand what is the impact of these things in the real world, because no company nowadays operates in one particular factory. We are operating in a multi-factory model, also in a multi-country model. So to understand what is the impact of my change, one small change in my which I want to implement in one particular platform or factory, how can it impact other factories? It's a large experiment, right? You need not go to a physical factory all the time and do that. Hence, the concept of digital twin. So if you take the example of a small machine, you can replicate the whole function in the cyber world, in the IT world, and simulate the whole experience which you want to give to a real world, simulate the whole experience in the cyber thing. Look into the success factor, success, failure, and all that, do the testing, and then take it to the real world. This is how the modern testing and cyber world, or the uses of cyber physical systems, it's also called CPS, is being used in the industry 4.0. And on the right side of the slide, you will find the different elements which augment this behavior. While I want to touch upon, while we proceed to the rest of the slides, I wanted to touch upon this COVID-19 situation. All of us, each one of us, are affected by this particular factor. Everybody is locked down, not only in our personal lives, but also factories, manufacturing industry, every industry in the world, travel transport industry, every industry in the world is heavily affected by this. So while you can go to the internet and find numerous reports. I think all the consulting firms have all come up with multiple reports and multiple suggestions. What are the impacts in different industries? I won't go to that. I'm trying to go beyond that because I believe each one of you can go there and already have looked into your respective kind of impact that you will have in your respective companies and industries. I want to touch upon, in the Indian MSME scenario, what would be the most possible aspects or changes that we should be looking at going forward. When I say going forward, I'm referring to when this COVID-19 situation is over very soon. My prayers are there, all of you. Once this goes away, what is the situation that we are staring at? There are obviously multiple ones, but I want to jot it down and segregate that into 4 main elements which you see in this screen. One, all of you are aware that there's a huge supply chain disruption. Because of the supply chain deadlock that has happened, manufacturers who have produced something, they are not being able to ship, they're not being able to get raw materials, the entire thing has gone for a super deadlock. Second, even if the COVID-19 situation is over, the fear or the concern among laborers to come back to office, come back to their factories, work, resume work in the previous fashion is not going to be the same as we knew a few weeks back. Just a month back, everything was fine. But going ahead, every company is going to take some actions on how we do this. Third is this whole China angle has been questioned. I'm sure all of you have looked into multiple reports, and that have come in the newspapers as well as the press. Already, big manufacturers are thinking of a non-China strategy. People are thinking of moving out. Moving out where? There is no answer yet, but I'm sure a significant portion of that move out will happen to India. So I believe India has a big opportunity, especially in the manufacturing sector. And if large companies come down to India to make their offshore operations, they can also China angle. I believe the MSME sector is going to benefit hugely from this small change. It is a small change in the global angle, but it will be a huge change from an India perspective. And the third, MSME sector is always driven by the banking, the financial aspects. So the big change can be how the banking and the financial institutions affect their roles, and their policies affect the MSME segment. I wouldn't go to the answers yet. I'm just proposing the aspects, because I will cover the Industry 4.0 and try to address through Industry 4.0 how can we see what are the elements that we can take out of Industry 4.0 which can help address these four towers, as we say. Okay. So challenges in the manufacturing industry have been listed on the left side. I don't want to list all of them, but if you can see, all of these should make sense, should affect your respective lives in the manufacturing segment. So all of you are manufacturers yourselves. You are primary suppliers to Tata Steel, so you understand the steel industry, and these elements, for example, supply chain logistics, industry compliance, is a big thing that one has to take care of. Aging workforce, knowledge management is a key problem, accuracy forecasting, and so on. These are the primary challenges, and let's see how these things are affected, or how Industry 4.0 looks into the whole topic. So if you see on the right side of my slide, we have several boxes, and these are 8 boxes around the Industry 4.0. You can say these are 8 different flavors of Industry 4.0. So there's no one single answer through which you can answer this address this whole topic. I'll try to address most of them as I go on. First, the most popular is the usage of Internet of Things. So listening to machine conversations. So I'll try to play this.
Highly accurate landing on floor 8.
Copy.
I'm assuming
starting my way up.
the audio is
Excellent.
this audio. Otherwise, you can
Just
also make out
5.3
from
meters up to floor 10.
So let me describe what is happening here. Okay, this is an elevator, Pony elevator, in one part of the world, and the different sensors that are attached to the different machines and the parts of that Coney elevator, they accurately measure every action, every movement of that elevator. It actually measures in a
Thanks.
Doors open for 7.6.
Yeah. So if you see, it is measuring every action of that particular elevator. It is measuring at what point of time it is halting at which floor, and so on, how much it rode, just rode 5.3 meters up to floor 10, how long the door was open, and etc. All these responses are robotic. These are not manual. These are coming from the machine itself, and the machine is capturing in every second. This data is being captured and taken to a central cloud. So I'm just talking of one particular lift. There are millions of pony elevators across the world. So this solution has not been implemented in almost every pony elevator. No, it is not that you will find the same solution in your home elevator, but in several, almost hundreds of pony elevators across the world, from Beijing to San Francisco, this is being used. Now, what is the usage? Once such action, such activities, every activity of that particular elevator is tracked in such a minute detail, the usage of analytics will help you to predict the next failure that the lift might have. For example, in your home elevator, let's say the scheduled maintenance is after 3 months. Depending on this particular data, which is being captured in real time, you can, if you're a Kony engineer, looking at the data, you can make out the depreciation level of a particular machine or part. You can accurately predict when it is going to fail in the future, and based on this particular data, you can take a call that, okay, I do not need to send my engineer 3 months down the line. I can send him maybe 5 months down the line, because the lift is maybe underutilized. If it is overutilized, you can take a call, maybe I need to send the engineer 2 months down the line, because you are being able to capture this real-time data without even visiting the premise. This is a classic example of usage
6 seconds on floor 10.
Acknowledged. 7.6 seconds on floor 10.
Up speed 1 meter per second.
Adding that to my analysis.
Doors.
So I'll pause here in the interest of time. So this was an example of Kony elevator which I wanted to show. Second was actually in the area of steel industry itself. Another example of Industry 4.0, another example of how IoT and machine analysis is being used. So let me know if you can see this video. This is a picture. It's actually a video. I'll soon run the video, assuming all of you can see this. There's no audio in this particular video. This is a camera inside an oven, and what you see there is a steel sheet. It's a steel coil that is being baked inside that oven. Okay, if we run the video, you'll be able to understand. While the coil is being baked, there are multiple flames that are being created. Because there's no fire, but you are trying to bake it in a fireless medium. However, because of heat, there are a lot of fire flames that are being generated. Now, this is a regular feature in every steel plant. What is the output of this entire exercise is that after some time, after the steel sheet is baked, it comes out and you have this particular steel coil, but there are a lot of impurities inside the steel sheet because you cannot control things which are inside the blast furnace, so the oven. In this case, since we have put a camera inside this, we can detect the different flames. If you see this video, there are multiple flames coming up at every microsecond. And this camera, with this analysis, tries to capture every flame that has come. And not only does it capture, it also tries to understand and analyze the size of the flame. So it says, looking at the video, it says, do you see different flames are coming up, and it tries to understand what is happening, flame size, small, medium, large. It is trying to capture at every possible moment. Now you can ask me, what is the benefit of doing that? What do I gain out of it? What I gain out of it is when the steel coil comes out, I have a full report of how much time it spent inside that oven, how many flames in small, medium size, large, how many flames did it encounter. And remember, occurrence of every flame means that there is occurrence of gases, and those gases are actually going inside your steel coil. So the moment it comes out, because of the solution, you can quickly predict that amount of impurities in terms of gas bubbles that has gone inside the steel coil. This is another classic example of usage of Industry 4.0 in the steel manufacturing. I'll quickly move. I'll quickly move to the other elements. So I just covered how we through the combination of Internet of Things, system integration, and big data, the data analysis, which we gave this example how we can do that. The second example which I wanted to talk about is usage of blockchain. I'm not sure how many of you are aware of this concept of blockchain. It is constantly in the news, cryptocurrency and everything, blockchain. So I'll give you this example from the mining industry. What you see here is a full flow of the mining industry, and what it says is look into the process part, or let's say if you go down to the bottom part of the slide, it shows all the steps an iron ore goes through from being mined to the final ending up with a particular user. And in between, it goes through multiple logistics, smeltering, let's say battery manufacturing. If I imagine this to be for battery manufacturing, nickel or other metals. If you see this particular iron ore, after it was extracted from a particular mine, it undergoes a lot of changing of hands. What blockchain says, and it does, is that every transaction it goes through, you will not look at this transaction in a standalone manner, but you will keep on adding this transaction to a central ledger. When you keep on adding these in a central ledger, you basically keep history of this particular iron ore when it changes hands. So it keeps on changing hands, one person to the other, one process to the other, then it ends up with some logistics person, the truck, or goes to a ship. It also changes countries, goes from one country to another country. Let's assume this particular iron ore, it can be a diamond also, that originated from somewhere in Africa, but then it goes through multiple countries, logistics partners, and then at one point of time, it ends up to a manufacturer. In between, it changes so many parties, so many countries, but every transaction it goes through is being tracked in a central ledger. So every person, every logistics partner, or every partner who takes part in this has to agree in this whole framework that yes, every transaction I will try to track it. I will submit this transaction to the central ledger board, and at the very end, when you find a certificate of authenticity of this particular ore, because you now know the sole origin of where this, let's say, particular mineral has come from. To give you an example, I don't know if you there's a very famous Leonardo DiCaprio movie called Blood Diamond, which was around 10 years back. Blood Diamond, the very famous movie, it dealt with this problem of illegal diamond mining in Africa. Illegal diamond mining or many other minings in Africa and many such countries is a big problem for the United Nations. So when you and I go to buy a particular diamond in diamond store in Calcutta, we are not so bothered whether this particular diamond was mined in a legitimate manner. What do I mean by legitimate manner? It means that no slave mining or slavery was used. You won't believe, even today, many parts of Africa, slavery is still in use and under the umbrella of the local government. And United Nations is trying their best since many years to stop this. But you cannot stop this illegal mining or slave mining. And blockchain has come as a very useful way to track this entire thing. That when I have this system, this particular system in place, I correctly know the origin of this particular diamond or this particular mineral. So I was talking about battery manufacturing. Um, cadmium, cadmium, the about 60 to 70% of the world's entire cadmium is being used by the battery manufacturing industry. Now, thanks to United Nations and also the help from different respective governments, um, companies like Exide or Duracell, they have signed up to this. Also, a lot of auto manufacturers who are also users of car batteries. So for both for cathode production as well as the users of nickel, cadmium, they have agreed that they will only use legitimate mined minerals, and which means how do you know whether this is legitimate mine? Because you're buying from somebody. Using looking at the entire chain of data, entire huge ledger that lies in front of you, you can quickly make out that this is a uh, legitimate mine thing. Moving on to how can be blockchain useful for you in the MSME sector. I listed down three main issues, three main areas rather, where this can be useful. Firstly, uh, do not know how many of you know that the whole concept of blockchain came from the from the finance sector. If you heard of cryptocurrency, that is how blockchain emerged. So the entire MSME sector, as I said, post COVID-19 also is being highly affected by the finance, so the bank loans, etc., tracking. And while large corporations find it easier to get finances, we know that there are a lot of MSMEs who do not get finances. So bank loans, etc. That is one area. And also I listed that according to the World Bank, the global demand from the MSME segment in bank loans is more than 2 trillion. However, only 15% of them actually get it. So this is a huge area where blockchain can help to establish the legitimacy of MSMEs, also the source of financing. If you look from the government and the bank's point of view, to understand the source of funds is one particular area where the government can look into. Second is the scale of operations. In MSME segments, especially there are too many intermediaries and the operation costs are too high. That can always come down when you go for a smarter contract. The Western world has already moved into it. People use smarter contract. You do not digital and smarter contract. That is, the big benefit of that is you can totally eradicate the intervention of lawyers and brokers unless you absolutely need it. For simple things, simple contract stuff to be made, which are normal stuff, you do not necessarily need the intervention of lawyers. It slows down the entire process. Blockchain can come in and help you in a big manner in that particular area. And then thirdly, as you would have understood already in the previous slide, authenticity or transparency. As I was explaining to that mineral flow example, at the very end, if you are lying at the very last end of the entire chain, you can quickly find out what is the authenticity of that particular mineral. Or it can also help you in understanding the authenticity or the sourcing of different parts and machinery components if you are a procurer of such a thing. If you are an MSME manufacturer, a participant, I think this is one area you can quickly adopt. I am aware of many blockchain organizations which operate in a very small manner. I mean, small in terms of people size, but quite large in terms of business. Just imagine it's not a huge solution that you need to run, but the impact, the whole entire scale that you can grasp. In the previous example, I showed you through one solution, you can track the entire mining industry, one particular mineral, end to end, which cuts through many large organizations, many large countries, and so on. If you are a MSME participant, it is not a huge investment that you have to do in order to take care of that. Before I move to the next topic, I wanted to go to the question. Okay, what is the way of, there's a question that has come, what is the way of the incoming companies will get to know that we are MSME? There was a question of what is manufacturing lighthouses. I'm not sure I understand the question on what is manufacturing lighthouses. It was not there in my presentation, but I believe it was what you are trying to refer to is manufacturing solution areas, or organizations which generate manufacturing solutions, etc. If you can repost your question, that would be very helpful. Just quickly trying to, in what situation is this situation? What is the major challenge for supply chain? Yes, thank you. That's a very important and pertinent question. Major challenge for supply chain is obviously supply chain deadlock, and different companies, especially the role of government, is very important in this particular scenario. If you heard Narendra Modi's speech today morning, he was also addressing the same question, which means the awareness of this question is with almost the government. How supply chain, I do not believe, will restart in a very quick fashion as we speak. However, it has to slowly start with the acceptance of, first of all, the travel transport entire industry. A lot of ships and the airline industry is completely strapped. So our logistics and goods and minerals which are not passing through the chain at all. The acceptance of the eagerness of acceptance of different raw materials in different countries is also questionable. I can give an example. One of the largest ball bearing, the world's largest ball bearing, I won't name the company, ball bearing manufacturer based out of Sweden, has completely gone on hold because they do not have anybody to sell it to. They are a big procurer of steel from different parts of the world, and they manufacture these ball bearings and the automotive parts. But there is no company, whether it's Tata Motors or Volvo or Volkswagen, nobody's procuring those parts because it has come to a stop. So what is the answer? The answer lies in the demand. I think the finance, from the financial point of view, unless there is money at the end of the day in the hands of the consumer, people are not going to start buying. People are not going to buy cars or even simple small toothbrush. End of the day, it has to be the need. That need would generate and unlock this deadlock, this entire deadlock around supply chain, which I believe is the answer. But the different governments are trying to resolve this through different incentives and so on. I believe, so let's see how that. See any more questions. We'll take more as we go on. I will quickly move to my slide, which is around cloud computing. The other element of Industry 4.0 is cloud computing. If you look into this particular slide, this is actually inside a factory, and there's a topic called IT/OT integration or shop floor to top floor integration. We understand, all of us definitely understand the shop floor scenario, what happens in the shop floor, but there's also top floor, which is the headquarters. At every level, there are different applications, there are systems which do not talk to each other. And this is one big area where multiple elements inside the inside Industry 4.0 are coming together. Usage of cloud, usage of something known as edge computing, which is computation not in the cloud level, but also at the factory level. And thirdly, the usage of AI tools, which are to do with a combination of sensors, IoT, and so on, and analysis, which tell you when something is going to fail, when something is going to happen, what is the prediction, what is the probability of success rate of a particular element going live. So usage of AI tools. AI itself is a huge topic by itself, which we should address in one particular session. But there are different elements like acoustic analytics, visual analytics. I gave you the example of visual analytics in that steel manufacturing. Acoustic analytics deals with listening of sound. Believe me, there are solutions now which tries to listen to the sound of machines and tries to predict whether the machine is right or wrong, it's a good sound or bad sound, whether it's a problematic machine and so on. And then we are moving into a topic of augmented reality and virtual reality. If any of you are aware of what that is, augmented reality and virtual reality, these are they started off in games, video games, which are being used by children, but nowadays it is being used by different industry. If you look into this particular slide, you will find 4 different examples of actual live examples where big corporations are using it. For example, the first one, augmented reality is being used by many companies. The example which I gave was Jaguar Land Rover. They're using this for personal training. So a particular person, if he or she is unable to be on the spot at that particular time, is being used, he or she can use this augmented reality solution in a small tablet, and over in a virtual mode, he or she can be trained looking at that device. So let's say I take this device in an augmented reality solution, I point it to a particular machine, and the solution will tell me the different part, what is the meaning of different parts, how each part works. It is like a full manual that opens up in front of me. There are many companies, many manufacturers are using this as I speak. Second, on the right side, this famous steel company, European steel company, ThyssenKrupp. You see this example, ThyssenKrupp is using Microsoft HoloLens. Microsoft HoloLens is the augmented reality, a virtual reality glass which you wear, and then your customized solution starts to play. That person is wearing that particular glass, looking at that that home steps, and accurately measuring the width and the length of the different steps, even though the actual stairs do not exist. So he is imagining that if the stairs existed, what is the width and the measurement of each particular stair. Third, you see Boeing. The example which I gave was for Boeing. Boeing, one of the world's largest commercial aircraft manufacturer. They are also using augmented reality for product assembly. So the design of several parts of the plane, they are trying to simulate this whole experience through this particular application. By the way, all these 4 examples are actual examples which you can find in the internet. You will find more details in that. Just try to Google them. They are not secret examples. They are publicly available in the internet. So feel free to just Google about Jaguar Land Rover, how Jaguar Land Rover is using this. And lastly, the example which I was trying to give was a famous company, Caterpillar, which makes such large trucks and machines. They're also using augmented reality in the maintenance area. So these large machines, etc., they have to be maintained without physically visiting them all the time. Even if you visit, how do you make out from this large, complicated machine what each part is? What is the meaning of each particular part? Wearing this particular Microsoft HoloLens and this augmented reality solution, it gives you these insights of what is the meaning. It's almost like a training manual. Since we have covered most of the stuff, I wanted to address the previous slide which I had. What is the scenario in the COVID-19 situation? So we had this slide, right? But now if you see at the bottom section of this particular slide, I tried to map the industry 4.0 elements against the 4 different problems or business areas which we thought. So what are these business problems? We predicted that post COVID-19, the manufacturing industry, especially MSMEs, would face these. These are not issues; these are realities, if I would say. And this would be the new normal going forward. Now, if this is the new normal, what are the elements? What are the weapons do I have to address this? For each one of them, I hope this addresses the question that previous gentleman had asked, that if there is supply chain disruption, how do I unlock that? You'll find the answer in this particular slide. There are many more answers, but I just try to map the most relevant ones, that what can we bring from the industry 4.0 things which we just learned, what can we bring it back. We talked about cloud, IoT, blockchain. This can actually help you in supply chain disruption. Usage of blockchain is very important. Supply chain is something that goes from one place to another, it changes hands. This entire area, blockchain plays a huge role. Usage of IoT actually helps you track devices, trucks, or articles or articles that are going from one place to another. And this whole solution around cloud is around capturing the data in one single place. So even though your particular truck is taking a particular asset from A to B, and it's going through a certain highway, the data is always accessible to you, because first of all, IoT. Second, the data is going to a cloud. So if you need not be in that site, you are in a central site, let's say Delhi, and you can track the whole data, because all the data is one single place. Second is labor problems. Labor problem is going to be an issue, and also aging workforce, because you have experienced people retiring, and also less people coming to work would be the new norm across the world. I'm sure also in India. So working in a virtual mode is very important. It is going to be, if you saw the virtual reality and augmented reality example in our previous slide, you'll be able to understand that it talks about people not visiting the site and yet being able to take action. This is also being complemented by the rollout of 5G, which is coming in a very timely manner. 5G rollout will help almost everybody, all manufacturers in this particular mode, because the faster the data flows, more easier is the solution going to be more applicable. The Make in India element, what are the different things that can help us in the Make in India thing? As we move ahead, obviously there's a demand of new factories to come up. Again, I put the examples of cloud, IoT, and augmented reality. On top of it, there is something called additive manufacturing. Because of lack of time, I could not cover what additive manufacturing is, but additive manufacturing is more to do with 3D designing. So before you design the actual stuff, you can make a prototype using 3D designing and try to understand how this is going to look, how this is going to behave, and so on. This is a modern way of giving life to something which you want to create. And lastly, the loan repayment issues. We already covered this. The entire financial tracking and authenticity can be tracked using the blockchain solutions. So different industry 4.0 elements and solutions to address our the key problems that are coming from the COVID-19 situation. However, I put this slide purposefully. For a true revolution, one must always rethink the process. The process is very important. The steps that we take are very important. And let us all understand, ladies and gentlemen, that Industry 4.0 is a new frontier for different manufacturers. You cannot move away from it. It is here. It is not going to go anywhere. It is 4.0. It is not 3.5. It is not 2.5. It is not 4.1. The world has moved from 3.0 to 4.0. So what do we do? It is very important, especially if I'm an MSME person, I have to be ahead of the curve. There are multiple competitors in this element. I'm not the only one. If you are a large manufacturer like Tata Steel, that's a different thing. There are very few players in India as well as in the world who are in that scale. But if you are medium-sized, small manufacturer, small scale person, small scale enterprise, I have to understand and keep in mind that there are many organizations who operate in my scale, and I have multiple competitors. Everybody wants to be successful. The reality on the ground is, however, and this is taken from McKinsey, the need for having a digital strategy on the ground is paramount for every MSME. Before you go on adopting things, you have to uh, have a digital strategy in place. There are multiple. I showed you 8 elements in Industry 4.0. Do you need every one of them? Yes, no, maybe not. What are the things that I need? The reality on the ground is that only 16% of uh, MSMEs in India have a digital strategy in place, and out of that 16% population, only 24%, out of the 16% have clear responsibility. They have clear thoughts in their mind. Yes, I know what to do with it. They have a clear roadmap. They're clear in their projection. So 68% have now what is the expectation from the customer, your customers, when you sell your products to? 68% of the B2B buyers have tried to go online and do buying on their own. And I'm trying to talk about B2B and not B2C. The customers are already going online and trying to procure things without waiting for uh, small manufacturers to come up, small suppliers to come up. This is our market reality. Again, coming from McKinsey. So the degree of digitization is there are multiple. There are multiple problems because MSMEs struggle in terms of financial power, sponsors, etc., and the ability to sell to bigger companies, the users, of course. And there are multiple possible steps you can take in a small manner to come up to that element. So first of all, develop your own digital strategy. Reach out for help. Reach out to consultants. Your strategy should encompass the entire picture. And obviously, you have in your own organization, you need to have an innovation-friendly culture. Now, to end the presentation, I know at the top of the hour, I have 3 minutes left. If you are thinking, oh yes, I am a small manufacturer, I'm a small enterprise, the things which Sanjay just showed is super stuff, but these are impossible for me. Can I do this? Is it possible for me? I think this is impossible for me. To answer this question, I wanted to show you this small picture. This is a picture of a bumblebee, and every scientist who has analyzed this bumblebee has found out that every law of aerodynamics is being flouted by the bumblebee. According to scientists and according to the law of aerodynamics, a bumblebee can never fly. It can never make a flight. However, what is the reality? The reality is a bumblebee has been found to fly even higher than Mount Everest. So, ladies and gentlemen, there's nothing called impossible. I personally do not believe it. And at least for the MSME segment, this is very important. MSMEs, by the way, contribute to 70% of India's export. I'm sure you already know them. I'm hopeful that elements of Industry 4.0 would be adopted by you. Reach out for help. You can reach out to me. My coordinates, my contacts are out there in this particular slide.